Hello everyone. Here is a video to help you with some of the examples from class that you may or may not have had time to go over, depending on what class you're in. So I'll just start from the beginning of these application-y kind of ones and see how it goes. So this first one here kind of looks like one you probably did do in class. We have this triangle set up here where you have a triangle kind of overlapping another triangle. So if you look at your notes, you probably have that one. This one's not much different. The thing about this one though is they actually give you the parallel lines right off the bat. So if you had the conversation about using a converse there, you don't really need that here since the lines are already parallel. So the good thing is since they're parallel, I can pick all the pairs of corresponding angles I want. There's a pair of corresponding angles. Here's a pair of corresponding angles. And to be honest, that's really all you need. If you look at triangle YXW and triangle ZXV, you've got two pairs of angles right off the bat as long as you understand what the parallel lines can give you. Additionally, you could have used angle X congruent to itself by the reflexive property. Realize that both triangles have angle X in them. You could draw them separately. Draw this triangle separate from the big triangle. You'll see they both have X. And you got all the angles you could possibly need to get similarity. Okay, so if we can all just agree that these triangles are in fact similar, we can go forward. They actually give us the proportion anyway, so to be perfectly honest, you probably could have just went right to the proportion. I just kind of felt that would be a good idea to just explain why these triangles end up being similar. All right, let's just start filling in our pieces of the puzzle here. XW, I do not know what XW is, so I'm just going to call that little a. I'd use X, except X is already here, and I don't want to I don't want to confuse you, even though it would be a little x. So this is little a from X to W, so I'll just call that a over XV is this whole thing, right? XV is this whole thing. Well, this whole thing is made up of XW and WV, right? This may look familiar. You've done things like this probably, maybe a month or two ago, actually, beginning of the year. You've got this little piece plus this little piece making the big piece. So this A and this 5 make this. And no, that's not 5 times A. You're adding them. If this was a 10 right here, let's just pretend it was a 10, and that's a 5, and I said, how long is this piece? Nobody's going to say 50. You're going to say 10 and 5 is 15. So you write A plus 5. A plus 5 makes the whole thing. So this little piece is A, this little piece is 5. The two pieces added together make the big piece. There's your A plus 5. All right, that's a little tricky, but that's how that works. So XW is A, XV is A plus 5. We've taken care of that ratio. We're good to go. Equals YW, well, that's obvious. That's just 24. And ZV is an easy one. That's just 34. And I think we're ready to solve. So cross multiply, of course, 34A. Be a little careful with your algebra here. This isn't 24 just times A. It's not 24 just times 5. It's 24 times the whole thing, A plus 5. So I usually use parentheses here so I remember to distribute the 24 to both pieces. All right, so 34A equals 24A plus, I think that's 120. And then you can just do your normal solving for A here. So I'll subtract 24A from both sides and then divide by 10. So my A equals 12. And that's what they asked for. XW is 12. We are good to go. All right, so hopefully that helps with that one. Let's look at the next one. This one is a person, a diver, a lifeguard, standing next to their ladder. We know the lifeguard for sure is 6 feet 4 inches. We know that his shadow is 48 inches long. The ladder, we do not know. That's what we're trying to find. And we know the ladder's shadow is 6 feet long. And we're trying to figure out how many feet high this ladder goes. All right, so hopefully you can see the triangles kind of hiding in there. They actually give you all the tick marks. You know you have a right angle. You might not be able to see it in the video as well, but if you look on your sheet closely, there is a little marking here for that angle from the person's head, looking down towards the end of the shadow there. So from the head to the shadow, you can kind of see that creates an angle. And then the top of the ladder to the ground also creates an angle. Okay, from the way the sun is sort of creating the shadow. All right, so we have two angles for two triangles. That means we have angle-angle similarity. These two triangles are similar. We can use the fact that all the corresponding sides must be proportional. So let's take a look. We know the 6 feet 4 inches goes with the ladder. So 6 feet 4 inches goes with the ladder, which is X number of feet, right? That's the vertical part. and we know the shadow goes with the shadow, so little to big, just be consistent. 48 inches over 6 feet. All right, I'm looking at this and I'm not very happy with the way the units are set up because it's kind of confusing having feet and inches together. And I'm sure some of you might be looking at this saying, wait, 6 feet 4 inches, can't I just write 6.4? Not quite. It may be a little harder to tell with this example, but imagine if somebody was 5'10", just on the side here. Just imagine if somebody was 5 feet 10 inches. If you're saying this is 6.4, well then you're also saying this is 5.10. Right? You're basically saying this person is 5.1 feet. Well, there's no way that person's 5.1 feet because 5.1 feet is pretty much 5 feet. Okay, and this person's almost 6 feet, right? 2 more inches, they'd be 6 feet tall. So you can't really do that because unfortunately there aren't 10 inches in a foot. Okay, there's 12 inches in a foot. So you have to realize that when you're making these conversions. So what I would recommend is, you see how we have inches here? There's no reason we can't just convert this to inches, kind of like when we did the simplifying before. So 6 feet 4 inches. There's 12 inches to a foot, right? So 6 feet, this part right here, 6 feet times 12 inches for 1 foot becomes 72 inches. 6 feet is 72 inches. Well, 6 feet 4 inches would just be 4 inches more than 72. So that would be 76 inches over X number of feet equals 48 inches over 6 feet. And that's probably going to be your easiest way to go about doing this. I suppose you could try to convert the 4 inches into a decimal and just realize that you're going to have to set up another proportion to kind of figure that out so you understand, how to get it out of 12 instead of out of 10. But I think for most people, this might be the easiest way to go about doing it. If you want to have that conversation with your teacher, you're more than welcome to discuss how to convert that to a decimal. But for right now, I just kind of want to figure out how high this ladder is and move on, okay? So 76 times 6 equals 48 times x. All right, 76 times 6 is 456, 48x. So x is, what's that, 18? Somebody double check me there. Let's see. And that is definitely not 18. How about 9.5? I honestly don't know what I was thinking. So just, that's why we have calculators, right? Sorry about that. So 9.5 takes care of our x value. If I got an answer smaller than, 6 feet, well, then I know I did something wrong. As soon as I got that number, I felt like something was wrong. So this ends up being 9.5 feet. Okay. 0.5 you could do. That's not so bad if you want to figure out how many inches 0.5 is. Right? 0.5 is half of a foot. Well, half of a foot we know is 6 inches. So 9 feet 6 inches would take care of the ladder. Okay? All right, last one here. Let's see, what do we got? We're a little out of focus. Let me clean that up a little bit. There we go. All right, we have, again, the overlapping triangle. So I think we can all agree that we're going to have the same justification as before. Reflexive, corresponding, right? We know the parallel lines. So let's just get right to our proportion. So I'm looking at these triangles and I see, the little triangle has 2 of the sides given, right? I have the 40 and the 320. The big triangle, I'm trying to find the distance across this lake, which is the unknown here. So I know the 40 and the D match up because those are in the same corresponding positions. So 40 must go with D. All right, that's a good place to start. So the 40 goes with D the same way as 320, which is, the hypotenuse here really, goes with, and here's where most people are going to mess up, it's not 162. 162 is just the distance from here to here, right? That's not an actual side of the triangle. So it's not just see 3 numbers and throw them into a proportion. You really got to think of what corresponds with what. The 40 goes with D. The 320 actually goes with the whole thing. Right here, draw them separately for a second. Watch this. Watch this. It'll be so obvious when you just draw them separately. Here's the 320. Here's the 40, right? Here's angle A. Here's angle A. Here's the corresponding angle for these two, right? That's where B and the C are. Okay, and just to finish with the letters, at least I could do that, right? So there's the 320, there's the 40. Here's the D. What goes here? I hope you're not saying 162. 162 stops right about here because there's 320 more going down all the way to the end. This 320 is really on top of here. So this whole thing is really 320 plus 162, which is 482. This is really 482. So if you just look at these problems and you're just randomly throwing numbers in hoping they match up, you really got to think about it. Okay? All right, so 320 over 482. And now, once you get here, this isn't so bad. Once you get to this point, no big deal. 42 times 40, and that's 1680 divided by 320 is clearly not right because 482 times 40, there's no way that that's 1680. 482 times, that's what I try not to do these in my head because that's where I make silly mistakes. Divide by 320, 19280, 60.25. That makes a lot more sense. No way that's going to be 5, right? And that's another good thing. I did that on purpose. Yeah, that's right. Did that on purpose to show you that if you get an answer that doesn't make sense, you should know that something's wrong. If I get 5 something for this, clearly that's smaller than the 40. That doesn't make sense. Okay? All right, so main idea, get your similar triangles, get your similar triangles, get your similar triangles, and then once you get there, you just got to set up your proportions and make sure you realize what pieces go where. All right, hopefully that helps. If you need any help, please let me know, and I will see you guys later.